Welcome to Math 1314. This is section 3.5 on rational functions. Rational functions look like the following. They look like something r of x equals a item on the top, an item on the bottom, and both of these have to be polynomials, the things we saw in the previous section. So you can see here I've got the polynomial on the top, which is x squared, and I've got a linear on the bottom, which is x minus 2. So in question 1, we're looking for the domain of this particular function. So what I notice about it is it has a variable in the denominator, and I don't want that denominator to be 0. Because if it's 0 in the denominator, then it would be undefined. So I need to remove any number that would make this denominator 0. Well, I solve that. I get x equals 2. It's removed from my choices. Every other number is fine. It works. It's not going to make the denominator 0. And so I get the left part, which is minus infinity to 2, and I get the right part, which is 2 to infinity, and then we get u in the middle, which is to union them together. Alright, question 2. Same thing. I have polynomial on the top, polynomial on the bottom. I want to find the domain of this function, and I don't want that denominator to calculate to be 0. So any number that would make it equal to 0, I have to remove it from my choices. Alright, so let's take a look. Can we factor it? It's a quadratic. Let's see, 4x times x is 4x squared. I need two numbers that'll multiply to give me minus 15. Alright, so I've got 5 and 3. I just need to adjust the sign so I get this minus 7x in the middle. So I have a 5x here. I have a minus 12x there. That does give me the minus 7x. So I set each piece equal to 0. X minus 3 is 0. I get 3. I come to my number line and I remove them. And so I've got two things removed. And so what I get is the left part, all the stuff in the middle, all the stuff on the right. And since I've got three separate pieces, I have to union them all together. Here in question 3, again, we have a rational function. I'm looking at a variable in the denominator. So I have to remove any number that would make it equal to 0. But the question is, can this denominator ever calculate to be 0? Well, let's see. If I try to solve it, I would get x squared as minus 25. Or x is plus or minus the square root of minus 25, or plus or minus 5i. So the only numbers that make it 0 are complex numbers. There's no real numbers that would ever make it equal to 0, so there's nothing to remove. So the domain is everything. And another way to look at this is 0 squared plus 25 is 25. I'm squaring something. That's always going to be 0 or positive. And when I add in a positive number, I'm always going to be larger than 0. In question 4, we're looking at a graph and we want to answer some questions. Alright, so let's make this up a little higher. Now there's lots of different things we're looking at here. First off, where are the axes? Alright, so here's the x-axis here. So here's our x-axis. The origin is right there. Here's the y-axis there. So let's see, what are all these lines I've drawn here? Well, if I'm going this way, that's x going to minus infinity. Now, as I go this way, where's the graph going? Okay, well, here we are. Here's the graph. The graph is coming this way. Now, notice the graph is not running off to infinity. It's leveling off on this dotted line. Well, where is the dotted line? Let's see. -1, -2, -3. So as I'm going this way forever, the graph is leveling off at -3. What about the other way? The other way down the x-axis, I'm going to the right forever. That's x heading to infinity. Well, what's happening to the graph? Let's go find the graph. The graph, as I'm moving to the right, the graph is coming up and going to the right this way. It's not running off to infinity. It's leveling off again to this same number, -3. So again, going to the left forever or going to the right forever, the graph is leveling off in both directions to y equals -3. Now this vertical line is called a vertical asymptote. Now the vertical asymptote is where? It's hard to see, but it's here at -1. So let me draw it over here a little better. So here's -1. If you're walking, there are two directions where you could head toward the -1. So if there are two directions to head toward that place, we need a way to talk about which way is which. Well, if we come in from under -1, that's what this little minus is up there. And if we're heading to -1 from the right side here, so we're heading this way down to it, that's what that little plus means. So if I'm heading in this way to -1, where is the graph going? Well, let's see, where's my graph? So as I'm moving this way, the graph is running off to -infinity. What about the other side? As I'm coming in this way from underneath -1, the graph is running off to +infinity. And so we collect all those pieces of information together where it's leveling off to -3, running off to +infinity as we come in from the left, from underneath -1. As we come in from the other side, we saw it's going down to -infinity. And then we answered the question about as we went to the right forever, it's leveling off at -3. Now let's see, is the graph increasing somewhere? Well, let's see. If we're walking from left to right, I'd be going up here. I'd come in from -infinity and I'd be walking up there. So yes, it is increasing. Are we ever going down? Are we decreasing? No. So where are we increasing? Well, let's see. I'm increasing on this part, which is -infinity to -1. And then I'm increasing again on the other side. We don't include -1 because the graph is blowing up there. So that's not part of this interval notation. The domain is everything except -1, the place it's blowing up. Now, what about the range? How high and how low does this go? Well, you might think it is minus infinity to infinity because it's going up forever and down forever. But remember, it never touches minus 3. It's just leveling off there. Let's go back and take a look at the graph one more time. See, it never touches minus 3. It's leveling off at those two places. So it never produces an output of minus 3. It just gets close to it. And that's why down here on the range, there it is. Down here on the range, minus 3 is not included. Vertical asymptote is that dotted line where the graph runs off to plus and minus infinity. Horizontal asymptote, so two words here. Vertical asymptote is where the graph tears to plus and minus infinity. Horizontal asymptote is where it's leveling off on the two sides. Alright, question 5. Let's look at this new graph. What do I see about it? Well, as always, first locate your axes. So here's the x-axis here. Here's the y-axis over here. Here's the origin. Let's see, I got this vertical line here at 1. Okay, so that's my vertical asymptote is at 1. Let's see, where is this dotted line? Let's see, minus 2, minus 4, minus 6. This is at minus 4. So we got our vertical asymptote is this dotted line. So vertical asymptote, x is 1. We've got this dotted line, which is our horizontal asymptote, and that's y equals minus 4. So as I'm coming to the left forever, we're leveling off at minus 4. As we're going to the right forever, it's leveling off at minus 4. So that's what these two statements are saying. What about here at 1? Well, remember, I can approach it from under and above. As I come in from above, I find the graph, it's going up forever. As I approach 1 from underneath, the graph is going up forever. And that's what that's saying. The domain is everything except the place where the vertical asymptote is. I can see this is a mistake. So here this is should be 1 and this should be 1 as well because 0 is over here. The range, let's see, it never gets to minus 4. It is going up forever, so minus 4 to infinity. Alright, and we talked about all of those things. Where is the graph increasing? Let's see. Well, let's see. On this piece here, I am going up. So on that piece, we are increasing. And on this piece, we are decreasing. So yes, there is increasing and decreasing. Now where was this? Well, remember this vertical asymptote was x equals 1. So this should be 1. And similarly over here, we're decreasing. This is at 1. My bad for believing back on the graph it was at the y-axis. So it is at 1. Let's see, domain we talked about, range we talked about. I need to fix this up too. This should be 1 and 1. Vertical asymptote, 1. Horizontal is correct. Alright, question 6. Where is the vertical asymptote? Well, the vertical asymptote is going to be where the bottom is 0 but the top is not. So t minus 4 is 0, so t is 4. There's our vertical asymptote. In question 7, how does this thing behave? That's what we're looking at. We'd like to know, how does it behave? Well, how it behaves depends upon the dominant parts of the top and the bottom. So, looking here at this, the dominant part is this x squared piece. The dominant part on the bottom is this x squared piece. And so it really looks like this, but you could cancel the x squared and you get minus a half. So the dominant parts tell me that as I go to the left and right forever, it looks like y equals minus a half, which says that the graph is somehow leveling off on the two sides at minus 1/2. Another example, so looking here, I have 5x over 5x minus 11 over 3x squared plus 4. I'm looking for the dominant parts. The dominant part here is the 5x. Dominant part here is 3x squared. One of the x's cancel, and so on the left and the right it's going to look like 1 over x, which means that the graph is going to level off to 0. A small bit more on vertical asymptotes, not on a test, but just some information for those of you going onward. So, when is this 0? Well, it's 0 when x equals 2, and so you have a vertical asymptote there. This is a place where the denominator is 0, but the top is not. Here on g, I do have a variable in the denominator, and you might think it's going to have a vertical asymptote at 2. But the problem is 2, while it does make the bottom 0, it also makes the top 0. So they're both 0 at the same time. What happens in this case, instead of a vertical asymptote, you get a hole in the graph. It's just a blowout. There is no vertical asymptote there. It's just that hole. So vertical asymptotes occur when the bottom is 0 and the top is not 0.